Hi everyone. This is a shelf cloud I recorded from my rooftop some time ago. I really like it. So I decided I need a permanent camera on my roof, and a good one of course. I ordered this one from AliExpress. 48 megapixels. That's a lot of pixels. 8000 wide and 6000 high. Oh, and it also has autofocus. Then the package arrived, rather quickly I might add. Only 5 days. The box is somewhat deformed, but not damaged. Let's open the package and see if the camera is still in one piece. The packaging material in the box should protect the product rather well on these long trips from overseas. So none of that is in the box, but still hopeful. What's in the bag? Another bag with the camera module and the JST to USB connector that lots of these modules use. The wiring of this, however, is not the same. There we have it. On the front we have a very clean PCB, with just the lens and autofocus assembly. In between the PCBs, the sensor. And on the bottom, all the computing equipment. I suspect the CPU to be under the heatsink. That's what I would do anyway. Let's see if it actually works. This is the Windows Camera app. And this is the camera in a temporary mount. The JST connector is on the back side. Then we plug it in. USB detected. And the camera is found. Hey, that's me. Hello everyone. Quality looks alright at first glance. The Windows camera can't handle high resolutions, so I set up VLC Player to do that for me. So the module is actually capable of outputting that resolution. But how good is it really? Let's figure that out. First I need still images from the module. I do this in my room with constant lighting and of an object with lots of details. I actually took multiple pictures so I can select the best one. Then I do the same with my go-to camera, the Sony ZV-E10. This is so I have something to compare the new module with. I then feed the image to a Python script I made. It will analyze scaled versions of the image for the amount of information it contains. Doing this, we can create a sharpness profile for the camera module. I put the number results into an Excel sheet for the module, my regular camera and a dummy low-resolution camera. So, nice graph and all, but what are we looking at? First, the legend at the right shows us what line is what camera. The numbers at the bottom, the x-axis, corresponds to the left column, the resolutions tested against the images. So, the left of the graph is 6000 pixels high test and the right around 200 pixels high image. The numbers on the y-axis are not useful on their own. They are only for comparing against the others. Now let's walk this through. Starting at the most right, all the graphs perform equally well, until data point 5657, the vertical resolution of around 600. This is where the dummy image with that height stops improving. The other two, however, are improving somewhat together. until data point 4243. Around 2100 height pixels. From there, the Sony camera takes the lead. Short note, if the USB module were upscaling, then I would expect the line to somewhat flatline at some point, like the dummy image did at the bottom. So the resolution is probably real, but not of very high quality. To finish this analysis, these are crops from the images so you can compare and see the actual quality difference with your own eyes. Also not unimportant, I might add. If you like this video, thank you. That's nice to hear. It really makes my day. Until next time.